Remember what a graph is. It's the set of all ordered pairs connected on a Cartesian plane. Or you can think of it as all the pairs of x and y's that make the left-hand side of the equation equal the right-hand side of the equation. Let's try to think of these ordered pairs in another way. Let's put all the x's from our ordered pair into a group and call it the domain. Then let's take all the y's from our ordered pairs and put that into another group and call it the range. Now we know that each x in the domain is related to some y in the range. To show this relationship, we draw an arrow between them. So for this example, 1 is related to 3, 5 is related to 11, 2 is related to 5, and 7 is related to 15. But how are they related? Well, all the elements of the domain are related to some element in the range by some rule. We call this rule a function. In this example, the rule is to take each x value, multiply it by 2, and then add 1 to it. If we call this function f, then we can rename y f of x, since y is the output after you put x into our function. Think of it as x being transformed by f. Since y, or f of x, is the result of x being transformed by our function, then y is dependent on x, while x is considered to be independent. Given this set of ordered pairs and its rule, let's try to label and complete our picture. Note that we can name a function anything. It doesn't have to be f. Here is a case where we are given a set of ordered pairs, but we cannot define a function for it. Can you see where the problem is? Anytime you have the same x value going to 2 or more different y values, we say y is not a function of x. Visually, it looks something like this. Notice how these 2 points are stacked on top of each other. If a vertical line can intersect a graph in more than one point, then the graph does not define y as a function of x. This is what we call the vertical line test. Here's another example. We see that 1 goes to 3 different y values, 4, 5, and 6. Visually, this looks like 3 points stacked on top of each other. Thus, it fails our vertical line test, and we say that y is not a function of x. We can also see this occur in some cases when we are solving for y. Remember, square root produces 2 cases. This means if I were to plug in 1 into this equation, I would get 2 different answers. The first one would be square root of 3, and the second one would be negative square root of 3. If I plot these onto a Cartesian plane, notice how the points are stacked upon each other, and therefore they fail the vertical line test. So we say this graph does not define y as a function of x. One thing that students struggle with is the concept that whatever is inside the parentheses of our function is what we plug in on the right side of the equation. For instance, if I had a function that looks like this, I can plug in any number that I want. I can plug in any variable that I want. I can plug in any object. And I can plug in any combination of variables that I want. We can also apply algebra to functions, meaning that we can add functions, subtract functions, multiply, and even divide them. The key here is to replace f of x with whatever it's equal to. The same can be said for g of x. So wherever I see f of x, I just rewrite x squared, and wherever I see g of x, I rewrite 2x. If I want to evaluate h of 3, all I have to do is replace x with 3. When you divide functions, you have to be careful that you never put in an x value that creates a 0 in the denominator. Remember, we can never divide by 0. This would break the universe.